Welcome to the runtime error. This is the third part of the single linked list. I hope so you understand both the parts we discussed in the previous two videos. If you haven't watched my last two videos, I fully recommend you to watch the last two videos so that you can come to know everything which we are going to look in this video. In this video, we will be learning a traversing over the single linked list. So we are going to have a lot of fun in this video because we will be discussing the traversal techniques as well as the difference between the while loop and the for loop and many other disadvantages of the single linked list as well. So before we start a single linked list traversal, let's say for example if we got an array, say for example if my array has 1, 2, 3 and 4, 0, 1, 2, 3. If I have these 4 elements, how can I traverse my array? So I simply traverse my array using the for loop. I know if I equals 0, I go till n minus 1 and I will simply print all the elements. But the point is, we know that in array, every single elements are stored in a contiguous allocation, right? It's stored in a contiguous allocation. But when you come in terms of linked list, those are not stored in a contiguous allocation. You can see over here that the first node is present at address 10. The second node is present at address as 20. This third node is present at address 30, or it might be present at anywhere. So address of this linked list is not fixed. So can we say that just like array, we are able to traverse a linked list? Okay, take it as head and go till we go to the null. No, because the point is in array, we know that the address are continuous. Say for example, if my 1 is present at 100, this will be present at 104. And the difference between these two is 4 bytes, which is my size of my integer. But here is, this is present at 10. It might get possible that this node may be present at 200. So it gets as 200. If this is present at 200, it might be possible that this may present at, say for example, 306. So this will be present at 306. So there is no any fixed type or the fixed address for the linked list. But when you come in terms of array, it is fixed. My size of integer is 4 bytes, so difference between all the gaps will be of 4. 110, 100, 104, 108 and 112. So this is how my array is stored. So it becomes easier to fetch all the elements of array using my for loop. But when you come in terms of my linked list, how do we traverse it? Let's check. Let me erase this. So when you are dealing with linked list, we are not sure about its address. So what we will be using? There are the two things that we need to keep in mind. The first one is not sure about address. And the second thing is not sure about number of nodes. I don't know how many nodes are there. You might be seeing that these are the 4 nodes, but we know that we can create any node during my runtime. Say for example, again I have created here node whose address is 500. This is a null, so it will be containing as 500 and pointing to this node and contains the value as 3. Now again I created one more node. Now say for example I deleted this node. Now is it possible to use a for loop? For loop is used during the array, and in array we already know the size of that array since it is a compile time. But when you come to the linked list, we don't know the size of my linked list because we can create and delete element at any time. So it is possible using the for loop? Absolutely no. So from this we can come to know that there is a difference between the for loop and the while loop. So let's write that first. So first one is for loop, mainly used when you know number of iteration. For example, if we use the array, before the compilation of the program, we know the size of an array, right? We know the size of array in advance. Therefore, we can use the loop, for loop, because for loop is used when you know the number of iteration in advance. And the second point is while loop. It is basically used when you don't know number of iteration but you know certain condition, right? I hope so this makes sense. If you come to the array, we know the size of array is fixed, so the number of iterations are also fixed. Say for example, I have array of size 5, array of size 10, so number of iteration will be 5, number of iteration will be 10. But when I am coming in terms of linked list, here you might be able to see that there are this 5 nodes, but what if in future I delete this node? What if in future if I delete this node and add one more node? So you never know that how many nodes are there in linked list. But there is one thing in the linked list that we know what it is if we observe it carefully. How we can come to know that this is the end of my linked list? For sure, I need to make sure that is there any node which contains a null at its next, Absolutely yes. So this is node which contains a null at its next, which simply says that end of my linked list. Can I say if I contains any node which contains a null at its next part, then it means the end of my linked list. So this is the condition I told you. We don't know the number of iteration, but we know the certain condition, that is null. Here we know the number of iteration, that is the size of an array. I hope so you understand the difference between the for loop and while loop. Now let's write a code to traverse my linked list. Now I will draw a linked list once again. Say for example, I have my 4 nodes. This will be pointing null since this is my end of my linked list. This is my head, address is 10, 300, 70, 40. So it will be 300, this will be 70, and this will be 40. Right, now value is my 8, 9, 2 and 1. Head contains 10 part. Now what I will do is, we know that I told you in the second video that we need to keep one pointer so that we can come to know that the starting point of my linked list, and we are denoting with the help of the head. We are denoting it with the help of the head. Right, now I want to traverse, I need to go from this place till my last place. But the point is, should I change the head or should I use a different pointer? If I use the head itself, then what will happen? If I traverse my linked list, finally my head will go over here. Right, my head will go here. Now if in case again I need a linked list in my future, then if I try to find where is my starting point of the linked list, so it will give me here. But the point is, my linked list is starting from this position, which means I should not change the position of my head. Can I say, which means I should not change the position of my head, because if I try to change the position of head, what will happen? If in case I need to utilize the linked list once again in the future, it becomes difficult to understand where is the starting point of my linked list. So what I will do is, I will be using a temporary variable whose data type is node itself. So where it will be pointing? It will be pointing to the head, which means it will be pointing at this location. At this location, temp, which means no matter where I take my temp, my head will remain present over here, which means this will be always the starting point of my linked list. I hope so you got you. So now what I will do is, since I told you I will be using the while loop, so for now I will not be writing any condition. So what I will do is, I will be printing as temp of data. We know that my temp is located at here. This temp has two parts. One is called as data and the second part is called as the next. So I need to print the data. So what I did is, since my temp is at here, so temp of next, that is called 8. So simply 8 is printed with the help of this. Now what I need to do is, I need to move my temp to this next location over here. So what can I do is, my temp is at here. If I say temp is equal to temp of next, which means my temp is initially at here, temp of next is equal to 300, so it will go at this location. So temp will be pointing at this location. Can I say if I write it as temp equals to temp of next, right? My temp is at here right now, So what I'm doing is temp is equal to temp of next. So temp of next is 300. So value of 300 will be stored inside the temp, and the 300 is presented here. So temp will be pointing at this location. So this temp will be vanished, and this temp will come over here. Now again I will come at while loop. Now say for example initially it contains is true. For example it is true. Okay, my temp is at here. True. Temp of data. This temp of data is 9, so 9 will get printed. So the 9 will get printed. And again what I will do is temp is equal to temp of next. So temp of next is equal to 70. It will get stored inside the temp. So temp will move over here. So this temp will get here. Again my condition is true, and I'm using the temp of data. So temp of data is 2. So 2 will get printed. Now temp is pointing at this location. So temp of next is equal to 40. So temp will come over here. Now again the condition is true. So what now my temp is over here. Again the condition is true. The temp of data, that is 1, will be printed. And now what will happen is temp is equal to temp of next. So temp of next is equal to null. So temp is initially, now temp contains a null. Now again it's get true. Now again what I'm doing here, temp of data, but the point is temp is pointing to the null, which means I don't have any kind of space. But what you are saying is I need a data from that space. I don't have any space, but you need a data from that space. How it is possible? This will lead to a problem called as segmentation fault. So in order to avoid this, what I need to write is, what condition I need to write over here. Can I say, I can simply write this as temp is not equal to null. Can I say temp is not equals to my null? So let's traverse once again. Let's make a diagram with the help of this code. Okay, initially my temp is at head, so temp is pointing at this location. Temp is not equal to null. Yes, temp initially contains as 10. Temp initially contains as my 10. Temp is not null. Or temp of data. So temp of data, that is 8. So 8 will be printed. Now you come in here. So temp is equal to temp of next. So temp of next is equal to 300. So this get updated. So 300. Hence my temp will be pointing over this location. Now again I will come. Is it temp is equal to null? No. My temp contains 300. So temp of data. So my temp of data is 9. Temp of data is 9. So 9 will be printed. Now again I will come. Temp is equal to temp of next. So temp is equal to temp of next is 70. So it will simply get replaced by 70. Now my temp move to my 70 address, that is over here. Again I will check, is temp is not equal to null? Absolutely true, because 70 is not equal to null. So again it will come here. The temp of data, that is 2, that 2 will be get printed, and temp is equal to temp of next, so it becomes 70 get cancelled and goes 40. So my temp move to the next location, that is at here. Now again I will check, is temp is not equal to null? Absolutely true, because 40 is not equal to null. Temp of data, since the temp of data is 1, so 1 will get printed. Now temp is equal to temp of next, so temp of next is equal to null, so it gets null. Now this gets vanished, and it is pointing to the null, which means it is pointing to the space which does not exist. Now when I come, temp is not equal to null, but can I say null is not equal to null, which is absolutely false. They are equal. So we will come out of the loop, and this is our final traversal. I hope so you got me how the traversals work like, right? This is how we use a traversing method for traversing the linked list. We cannot use the for loop since we don't know how many nodes are present in my linked list. We need to use the while loop since we know there exists one condition which is null, which itself says that my end of my linked list. This is the way I use to move my pointer to the next location, right? So this is the traversal. Now I'm going to tell you one of the biggest disadvantage of traversing a single linked list. Since I'm telling you that we are traversing to its right side, in array it was possible. Say for example, if I have an element as 1, 2, 3, 4 and 5. In array it was possible, either I can move from first to end, or either I can come from end to first. But in linked list, but in single linked list, it is not possible to come from back to the front. It is not possible to come from back to the front, because this node mainly contains the address of a next node, but this node does not contain the address of its previous node. It contains the address of its next node. It contains the address of next node. This does not contain the address of its previous node. This does not contain the address of its previous node. They simply contains the address of their next node. So we are able to move only to this front side. We cannot traverse from the back to the front. This is one of the major drawback of the single linked list. So this is the three parts we have finished, that is insert the node at start, insert the node at end, and now we saw the traversal method. I hope so you understand this code. Let me erase this so that it becomes easier for you. Let me write the code once again. We'll write the code for traversing. So it will be void traversal. So how I will be writing? I will be creating a temporary temp which is initially pointing at my head. So what I will be writing is while my temp is not equals to null, what I need to do is simply print the data of that node, that is temp of data, and update my temp to its next location, that is temp is equal to temp of next. So this is the traversal function of single linked list. I hope so you got all the three parts of the single linked list. In the upcoming parts, we will be discussing the deletion part, that is deleting from single linked list. And I hope so you understand how to create the node, how to insert a node at start, how to insert a node at end, and most interesting part, that is how to traverse the single linked list. If you're really enjoying the way I'm teaching, do subscribe the channel, which gives me more motivation. Till then, have a happy coding. Let's see you in the next video.